Screen is visible?
Yes, sir.
So good morning to one and all. According to your syllabus, we have finished section 1, which was having 3 units. Okay. So first 3 units we have finished. The 4th unit, 5th unit and 6th unit, it will not take much time as compared to section 1. Okay. Only this unit 4 and 5, it will take time. Unit 6 is very easy and it will take only 2 to 3 hours. So the section 2, that is unit 4, we are going to discuss today. That section 2, unit 4, that is called transducer and instrument transformer, we are going to call. Have you heard the name transducers? Have you heard the name of transducer? Anyone? Is it audible or not? Hello?
Yes, sir.
Yes, sir.
Have you heard the name of transducer? ट्रांसड्यूसर का नेम मालूम है क्या? Yes?
Yes, sir.
Okay. So in the first year itself, you have studied some RTD, LVDT, LDR. You have studied the subject or not?
Yes, sir.
So that is, those are transducers only we are going to call. Actually, the transducers are the devices which converts one form of energy to another form. One form of energy to another form, they are going to convert here now. Just a minute, roll number 6, roll number 11, 33. So the transducers actually converts physical form of energy into electrical form of energy, we are going to call that one. So the transducer, the devices which converts one form of energy to another form. Again, the transducers are classified into different types are there. We are going to discuss those all the types. And the instrument transformers we are going to discuss here. Now, these instrument transformers actually we are going to call, that is, current transformers and potential transformers, which are useful for the measurement here now. Suppose 220 kilovolt is there, 22 lakh voltage will be there. In that one we cannot जाके measurement कर सकते क्या सबस्टेशन में ऊपर? अभी आपके गली में एक लाइन है, वो कितना वोल्टेज है बोल के जाके चेकिंग करते क्या आप? No. So that voltage we have to reduce into measurable voltage and we have to measure that one. Then according to the ratio we have to calculate that what is the voltage of that one. So which is going to reduce the voltage and we can measure the high voltage in the form of low. So to conversion purpose, we are going to use the instrument transformers. We are going to call that one. That is called instrument transformer. So those instrument transformers are, one is potential transformer, another one is current transformers. So these two transformers we are going to use in this chapter here. Now we are going to discuss what is the construction of current transformers, voltage transformers, what is the transformation ratio, how it is going to operate, and what are the different types of instrument transformers. These all the things we are going to discuss in this chapter. Okay. So we'll start. According to this, the syllabus of this unit 4 is, first one is the resistance temperature coefficient. Do you know that resistance? What do you mean by resistance?
Oppose the flow of current.
which opposes the flow of current over there. So that resistance characteristics, the function will, what is the characteristics of resistance for different temperatures? We are going to do this one here. So that is called resistance temperature coefficient. That is alpha. It is represented by alpha. We are going to call that one. If alpha changes for different temperatures, what is the value of resistance? It is going to indicate here. So resistance temperature coefficient, for increasing temperature, what will happen in the resistance? For decreasing the temperature, what will happen in the resistance? That one we are going to discuss. That is called resistance temperature coefficient. We are going to discuss here. Next, the definition of transducers and what are the classifications of transducers we are going to discuss. Next, in that one, so many mechanical transducers are there, active transducers are there, inverse transducers are there, passive transducers are there. So in that one, we are going to concentrate only on the electrical transducers, that is called resistance temperature detector, resistance variable differential transformer, linear variable differential transformer. These are called RTD, RVDT, LVDT. These three devices we are going to discuss here now. This, up to this part, RTD, RVDT, LVDT, this belongs to the transducers, and the next part, which is belongs to the instrument transformer, that is called current transformers and potential transformers. So in that current and potential transformers, what we are going to discuss? We are going to discuss construction and theory of instrument transformers. Is nothing but construction and working principle of current transformers, potential transformers, and types of current transformers, potential transformers. Then equations, the ratio equations and phase angle error equation for the current transformers and potential transformers, and the turns compensation, how we are going to compensate the turns for the current transformers and potential transformers, we are going to discuss in this chapter. It has two parts. One is a transducer part, another one is instrument transformer part here. So shall we start the transducer part first? According to your syllabus, this is 6 points are there. First 3 points belongs to the transducer parts, and the next 3 points belongs to the instrument transformer part. So this, it will take 3 class, it will take 3 class, total 6 class we can finish. Actually they have mentioned 8 hours or 9 hours, that is. Okay, so already we have studied this LVDT, RTD, it will not take much time also. So we'll start the resistance temperature coefficient we are going to discuss here. Can anyone tell what do you mean by resistance temperature coefficient? Just now I told that one, the definitions. Means what? What is the purpose of this resistance temperature coefficient? In the first year, it was not there for you, na? Yes. First year, I think it was not there. Resistance temperature coefficient what was not there. But some universities, they have added this one big derivation is there. Nearly 2 pages derivation is there. They have to do the derivation in the BEEE subject. They will add that one, but they have not added here. But here also there is no derivation. Direct formula we are going to discuss here now. So the resistance temperature coefficient is nothing but it is a resistance change factor. We are going to call that one. Resistance is going to change means it is resistance change factor per degree Celsius of temperature change is called temperature coefficient of resistance or resistance temperature coefficient. Actually, this one we are going to call as RTC also. It is denoted as RTC here now. Resistance temperature coefficient or temperature coefficient of resistance, both are same only. Per degree change here now, the resistance change factor, the resistance, how much resistance will changes per degree Celsius of temperature here now. Suppose at the room temperature, that is called, I think 14 degrees Celsius, you consider that one. For 14 degrees Celsius, I have 10 ohm resistance. If I made that one 15 degrees Celsius, then what is the resistance? It is a 12 ohm or it is 8 ohm, it is decreasing or increasing here now. So that factor we are going to calculate here now. We are going to measure that one. So that one we are going to call as RTC, that is called resistance temperature coefficient. So the change factor, resistance change factor per degree Celsius of temperature change. Here resistance will also changes. The temperature is also changing here. Change in temperature only we are going to measure, na? Yes or no?
Yes, sir.
From 14 degrees Celsius to 15 degrees Celsius, the temperature is changing. Then for 1 degree Celsius change, how much temperature, how much resistance is changed, that one we are going to measure here. That one we are going to measure here now. So the resistance change factor for degree Celsius of temperature change is called the temperature coefficient of resistance, or resistance temperature coefficient, or RTC also we can call that one. Can also call that one as RTC also here now. So this RTC, it is represented by a Greek letter or lowercase letter, that is called alpha we are going to call here. Alpha we are going to call that one here. Alpha here. The unit of the unit is, we are going to call, what is the unit of alpha? You have studied in the physics also, I think this. Yes or no? No one, sir. कौन remember करते सर ऐसा सांगते तुम्ही? हाँ? फिजिक्स वो भी 12वीं में स्टडी किया सर, अभी सेकंड ईयर में एंटर हो गए हम, फर्स्ट ईयर भी खत्म हो गए. फर्स्ट ईयर आल्सो देयर वाज ए सिविल फिजिक्स सब्जेक्ट ना?
Yes, sir.
Can you tell me what is the unit of alpha? ppm per degree Celsius, parts per million per degree Celsius, we are going to call that one here. ppm per degree Celsius. We have not written here, but so it is denoted or represented by a alpha here. No, alpha we are going to call that one here. So remember the definition of RTC, that is called resistance change factor for degree Celsius of temperature, or per degree temperature change also we can tell that one. Celsius remove karke per degree temperature change also we can call that one. It is called resistance temperature coefficient or temperature coefficient of resistance. So both are same only. Okay, yesterday we have discussed about that one. Current lags the voltage or voltage leads the current. Both are same only. Like that, temperature coefficient of resistance is same as resistance temperature coefficient only. Next we will go for the one formula we have used, that is directly we are going to consider this formula here. I will write how we got this formula here. So for the initial condition we are going to call that one. For initial condition we are going to consider the R reference, that is the conductor reference, conductor resistance. One conductor हमने consider किया, उसका initial reference or initial value at reference we are going to call that one. At reference means the temperature at 0 degrees Celsius are usually at room temperature, or 20 degrees Celsius also we can consider that one. So our reference is nothing but the initial value at the starting of the experiment. Kitna value hai, how much is there, and the T reference. At T reference, how much resistance is there of that particular conductor. Here we are going to discuss here now. I will take one conductor. I will take this one. This is one conductor here. This conductor resistance is how much for initial temperature here now. R reference also we can consider, R reference for T reference here now. What is the room temperature? For that temperature, what is the resistance here now? That is called reference resistance for reference temperature here now. The conductor resistance at temperature reference, T reference, usually 20 degrees Celsius, or but sometimes 0 degrees Celsius we are going to call here now. T reference is the reference temperature that alpha is specified at for the conductor material here now. For the particular material of conductor, the alpha is already predefined here now. That value we are going to consider, that is called initial resistance, initial temperature. Before calculation, what is the initial temperature? We have called that one here. Rule number 25. Are you there? Just now you have joined.
Yes, sir.
अभी join किए क्या?
Yes, sir.
So at T reference, temperature reference, the resistance reference we have considered here. Next, what we will do, the R is nothing but change in resistance for change in temperature here. Initial temperature say next which temperature it has increased or it has decreased. Based on that, the change in temperature is this one here now, increased value here now. So conductor temperature in degree Celsius, initial kitna tha, abhi kitna hai, now how much it is there. For T degree Celsius, what is the resistance of that conductor here now, that is called change here now. This is initial we are considering, means the R is nothing but final value we are going to consider here now. So what is the total change? R minus R reference, final value minus initial value, we are going to call that one. Actually, this one actual formula for it will start from here. I will just note down here only. R minus R reference, R minus R reference equal to, sorry, not equal to, I will consider it is directly proportional to the R reference, the reference resistance, R reference into T1 T minus T reference here. Actually this was the initial formula. Visible hai kya nahi? Is it visible?
Yes, sir.
This is initial formula we are going to call here now. But whatever this proportionality is there, by removing this proportionality, what we have added, I will add equal to here, means if I have added equal to, then the proportionality constant will come as alpha here now. That is called the temperature coefficient of resistance or resistance temperature coefficient, which is the proportionality constant for the RTC derivation here. The alpha came here now. From this equation, I will take the different color, this green color I will take down. R I will write here now. R equal to, from this equation, R equal to, when I will send this R reference into RHS side, here minus is there, it will become plus.
Yes, sir.
So R equal to R reference, whatever from LHS side se aaya wo plus mein likh do, plus I will write same equation here now. Alpha R reference, open bracket, T minus T reference, here now. T minus T reference. I will close this one here now. See here, which is the common term here? Here also R reference is there. Here also R reference is there. Yes. Here
Yes,
also
sir.
R reference. So I can write the formula R equal to, I will take R reference as outside here now. The common I will take here now. R reference equal to 1 plus alpha T minus T reference, yes, T minus T reference. We got the same equation now. You compare with this equation, this one R, here R equal to R reference 1 plus, this is alpha here, alpha T minus T reference here now. So this is the change in resistance to measure the change in resistance here now. Resistance temperature coefficient. Actually, we have to measure the value of alpha here now. So this equation we have taken as a reference here now. From this equation, we can separate alpha also. From this equation, we can separate alpha also. Alpha separate कर सकते क्या? Can anyone do this one? Tell me the formula for alpha. Tell me the formula for alpha. Just split this term. See here. R is there here. I will write R. This one you multiply here. R reference. R reference plus R reference into alpha. R reference into alpha T minus T reference here. Now can you split this one? Can you write the formula for alpha? Yes or no? To send this R reference into LHS side, it will become R minus R reference.
Yes, sir.
R minus R reference. ओल्ड अभी मैंने इनिशियल इक्वेशन चालू किया था वही हो गए. Yes.
Yes.
Equal to here already R reference is there. Again you take R reference and alpha. This term complete you write down here now. So from this one here it will become R minus R reference हो गए. Equal to this one I will write as equal to here. Now you write alpha equal to will you write the formula? Alpha equal to what you can write? Alpha equal to
R minus R reference upon R reference into T minus T reference.
R minus R reference, R minus R, I will write R reference divided by R reference into T minus T reference. T minus T reference. Some people they have joined now. अभी join कौन किए? अटेंडेंस नहीं दिया मैंने. मकरध्वज मोरे. What is your roll number? Just now who has joined, you tell your roll number for the attendance. Otherwise, you will have mark as absent only. Okay, you are not interested means what I have to do?
33 sir.
33 पहले ज्वाइन हुआ था ना?
वो तो पर 2 मिनट में लेफ्ट हो गया था नेटवर्क प्रॉब्लम.
ठीक है बेटा. I will add. So this is the formula for resistance temperature change here now. Okay. So I told here now for the initial condition, suppose 10 degrees Celsius temperature is there. For 10 degrees Celsius, there is a 2 ohm resistance is there. Okay, 2 ohm resistance is there. That is, this is called T reference. This is a reference value I will consider. T reference, this is R reference here. Next, what will happen? After some value, it will happen, it will changes into 12 degrees Celsius here. And the resistance will changes into 3 ohm here now. So what is the change in resistance here now and change in temperature? This is alpha equal to R minus RR, means what it is nothing but 3 minus 2. Instead of this 3 minus 2 or not this one. Final value minus initial value here now. R minus R, it will become give 1 ohm here now. 1 ohm. And the change in temperature is how much? Kitna change hoga idhar? 10 and 12 mein? How much it is changed? 2 degrees Celsius here now. 12 minus 10, that is called 2 degrees Celsius. We can consider 1 divided by this is 2. And what is the R reference? We have to multiply here now. 2 into 1, that is called 2. Into 2, that is called 154. 1 by 4 is nothing but alpha equal to how much? It is nothing but 0.25 here now. That is called the resistance factor. per degree change of resistance factor per degree Celsius temperature change here now. Either per degree temperature change hoga to the resistance will changes. If the resistance is changed, nothing but the per degree the factor of that is called resistance temperature coefficient will also changes here. समझ में आया अभी? Actually whole derivation solve करने का मतलब नहीं है. It is not important for you peoples. What do you mean by resistance temperature coefficient? If you have to remember this formula, you remember this one. Some textbook they have mentioned that one alpha net equal to R minus R naught also. R naught बोल के mention कि the T minus T naught or only T they have mentioned here now. Temperature here. This R naught here. At 0 degree Celsius they have considered alpha naught at 0 degree Celsius. The resistance temperature coefficient at 0 degree Celsius, and here at resistance, initial resistance that is called R naught, initial temperature that is called T naught they have considered here. Okay, here the resistance temperature that is called R is conductor resistance at temperature T, and R reference is the conductor resistance at T reference here. Now alpha is the RTC that is called resistance temperature coefficient. T is the temperature in degree Celsius that is called final value, and T reference is the reference temperature which is initial temperature we have taken here. Next what we have to discuss, the resistance of a conductor. The what are the different types of conductor, material of conductor? कौन सा material से conductor बन सकते? Yes. Different types of material of conductors. Conductor का material कौन सा है? Conductors. Different types of copper, aluminium. So actually we are going to call the materials of conductor is, we are going to classify into 3 types actually. That is called metals, semiconductor and alloys here. Metal means that is copper, aluminium, silver, this will comes over there. Okay, so semiconductors are nothing but these are the diode, ACR, these will comes over there, silicon and all the things. Yes, and the alloys is nothing but combination of aluminium and silver, combination of aluminium and copper mixed, that is called some 20% of aluminium, 40% of copper, like that. The mixed part we are going to call as alloy here. Alloys we are going to call here. So for the alloys, how the temperature will be changes? Alloys and metals parts only, that is metal part is nothing but any metal part you consider, you touch, the current will flow through that one here. How it is depends on that one we are going to call. So the resistance temperature coefficient actually that is called 2 types are there, that is positive temperature coefficient and negative temperature coefficient. From seeing this graph, what you are understanding here now? For the positive temperature coefficient, what you are understanding by seeing this graph? The x-axis we have considered temperature, and the y-axis we have considered that is called resistance in ohm here now. So at the initial condition, the temperature, the reference value we have considered, suppose here they have taken here now, that is the reference here now, T reference they have considered here. Next, after this one here, this is T reference we have considered and R reference. For T reference, this is T reference and this is R reference here. Okay, after this one, I will little bit temperature I will increase here now. So the temperature increase means the resistance should have to increase or decrease. So it is increased or decreased, you only check here now. At this point, it is increased or decreased here now. The resistance is increased or decreased? Increased here now. Again, some more temperature I will increase here now. Next, what will happen in the resistance? Increasing here now. So the temperature is increasing means the resistance of that material or conductor is also increasing here. Yes.
Yes, sir.
So for increasing the temperature, resistance is also increasing. That is called positive temperature coefficient. We are going to call that one. That is called positive temperature coefficient. If the temperature is increasing, you substitute here now. The alpha equal to, what is the formula? R minus R naught. R minus R reference divided by R reference into T minus TR. T reference here now. Just now we have calculated this one only. So R minus R, I will consider initial resistance was 2 ohm. Initial resistance was 2 ohm and final resistance was 4 ohm, or okay, 4 ohm. Then what is R minus R equal to? 4 minus 2,
2 ohm.
that is called 2 here now, into R reference is 2 only. Here T is nothing but I will consider here now 10 initial 10 degrees Celsius initial, and this is called 14 degrees Celsius here now. What is this one? 14 minus 10, how much it is? 4.
4.
4. So 2 divided by 8, how much it is?
1 by 4.
1 by 4. 1 by 4 is nothing but 0.25. Yes?
Yes, sir.
0.25 is nothing but it is a positive or negative here now?
Positive.
Positive. That is called positive temperature coefficient, we are going to call it. So this positive temperature coefficient is applied for the material that is called metals here. For the metals and silvers, aluminium, the positive coefficient of resistance is there. A positive coefficient of for a material means that its resistance increases with an increase in temperature here now. So the pure metals typically have a positive temperature coefficients of resistance, that is called aluminium, copper, gold, silver. These all the things we can call that one here. That is called temperature increase हो गई तो resistance will also increases here now. आपका घर में suppose somewhere you are going to use that copper wires, you are going to use that one. If the heat increase होगा तो resistance will also increases over there. So if the resistance increases, it is going to block the current. Resistance is inversely proportional to the current, yes or no?
Yes,
sir.
sir.
So if the temperature increases, resistance will increases. Resistance increases means again it will reduces the current flow here, no? So if the performance of that material or metal or part is going to reduce over there. So that is called positive coefficient of a temperature, we are going to call that one. Positive temperature coefficient here now. So next one we are going to discuss, that is called negative temperature coefficient here. So it is not clear actually. I'll draw here only from this diagram only. Is it visible? Visible hai kya?
Yes, sir.
I'll take the dark line. So this is x-axis. I will consider as temperature. I will consider as temperature here now. Okay. Temperature. Y-axis, sorry. P1 hai na? Temperature. Y-axis I will consider as resistance here now. I will consider as resistance. So what we'll do? For the negative temperature coefficient, I will draw one graph here now. See here now. This one. For 0 degrees Celsius of temperature, it has some resistance here. It has some resistance here. Okay. Suppose you consider the T reference is T reference is 1 degree Celsius. T reference is 1 degree Celsius. 1 degree Celsius. And the R reference at T degree Celsius is, R reference for 1 degree Celsius is, suppose it is 10 ohm. You consider that is called 10 ohm is there. Okay. So after the temperature decreases here, now temperature increases here. This is 1 ohm ko. The temperature either here, resistance is 10 ohm is there. Okay. Suppose the temperature will increases to 5 degrees Celsius. The temperature is 5 degrees Celsius. I will consider RT equal to 5 degrees Celsius. 5 degrees Celsius. Okay. So here you tell me either 5 degrees Celsius means the resistance here it is decreased or not?
Decrease.
Decreased here, no? So the R equal to I will consider as that is 6 ohm. You can consider that. That is called 6 ohm. So now you find the alpha. You find the alpha. Alpha equal to R minus R. How much it is? Nothing but R minus R. 6 minus 10. How much it is?
-4.
6 minus 10 here, no? 6 minus 10 divided by the reference is 10 here and T minus TR. T is how much? 5. Reference is how much? 1 here, no? So 6 minus 10 is nothing but -4 divided by 5 minus 1, it is 4. 4 into 10, that is called 40 here, no? 40 here. So 4 by 40 is nothing but minus 0.1. Minus 0.1 only, na? 1 by
Yes.
10. Yes? Yes or no? I am asking to you people only. 1 by 10, how much answer?
0.1.
0.1.
Point?
0.1.
0.1 only. But the answer is in minus here now. The minus indicates that is called negative only. Yes or no?
Yes.
Yes,
Yes,
sir.
sir.
For that reason, the negative temperature coefficient we are going to call. This negative temperature coefficient, the temperature is increases, then the value of the resistance it is going to decreases here now. So for the positive temperature coefficient, the resistance was directly proportional to the temperature. But here the resistance was inversely proportional to the temperature here now. If the temperature increases, resistance will decreases. If the temperature decreases, then resistance will increases here now. The materials we are going to use for the negative temperature coefficient is nothing but carbon, silicon, germanium. These all are the semiconductor material only, na? For the SCR, the BJT and all the things we are going to use silicon or germanium only we are going to use here now. So a negative coefficient for a material means that its resistance decreases with an increase in temperature here now. So semiconductor materials like carbon, silicon, germanium typically have a negative temperature coefficient of resistance. So for the positive temperature coefficient, the resistance was directly proportional to the temperature. For the negative temperature coefficient, resistance was inversely proportional to the temperature. But one more is there, that one they have not mentioned here now, but I will explain by personally, I will explain that one here. Some materials are there that is called alloys we are going to call here. Some alloys are there like a constantan, manganese. Have you heard the name manganese, constantan? Yes.
Yes.
So these materials, what will happen? There is no change at all in the resistance for different resistance, different temperatures. Resistance change nahi hote udhar. You can give 10 degrees Celsius, 100 degrees Celsius, 200 degrees Celsius, but the resistance will not change. Whatever the resistance is there, it is going to maintain constant for some aluminium, some not aluminium, some alloys that is called the constantan and manganese materials are there. So the temperature effect of those resistances, there is no change of resistance at all for different temperatures. There was no change of the resistance for different temperatures. We are going to call that one. So this completes the resistance temperature coefficients. You can ask if you have any doubts, you can ask. किसी को डाउट है तो पूछ सकते हैं. Any doubts? So it
No, sir.
completes the resistance temperature coefficient. It completes the resistance temperature coefficient. Yes, over. No doubts. No doubts.
No, sir.
Okay. So this was actually basic, that resistance temperature coefficient. Next we will go for the actual, that is called transducers. We are going to shift now. So transducers is this transducer is a device which converts one form of energy into another form of energy. That is called, we are going to call actually transducers and actuators. Sensors, have you heard the name? Transducers, sensors. Yes or no? Sensors तो मालूम है ना?
Yes, sir.
So you have your mobile only. During the call, you just hold that dark dot in your display. It will automatically display will off over there. So that is physical. Whenever I will hold that one, physically the brightness will changes and all the things. That is called physical quantity is converted into electrical quantity over there. You can call that an inside the electrical signal will go to the IC and it will give the signal to reduce the brightness here now. That is called sensors only here now. So transducer is a device which converts one form of energy to another form. That is, especially we are going to call that one as it may be, the conversion may be physical to physical or physical to electrical or electrical to physical. We are going to call that one. We can physical to physical also we can convert, physical to electrical we can convert, electrical to physical here. So for that reason, we are going to tell the definition of transducer is, it is a device which convert one form of energy to another form of energy. Already you know the example of strain gauge, thermocouple, thermistor, etc. You know already. Yes. So here the block diagram, we are going to basic diagram here now. Transducer is there here. One form of energy we are giving input, another form it is going to convert. If we have given physical form, then it is going to give electrical form. If it is physical and physical continuation or digital, we can convert that one analog to digital also we can consider. And if we have given electrical signal, it is going to get mechanical signal or physical, we are going to call that. So that is called temperature, thermistor and resistance here now. Temperature को हमने resistance को conversion कर सकते हैं. Already we have discussed just now, initial temperature was how much, if it is which material we are using, based on that the temperature we can convert into resistance here. So these transducers are classified into different types here. The transducers are classified according to the applications, external power supply required, nature of output signal here. So based on the power supply we are going to use here now. Based on the input and output we have classified into analog and digital. Based on the physical and that is electrical and physical, we have classified primary, secondary here now. Based on electrical and physical, again classified into electrical and mechanical here now. Transducer and inverse transducer we have calculated here now. The word opposite to the transducer, that is called inverse transducer. So the transducer, actually we are going to call that one as physical quantity is converted into electrical quantity here. So mainly we are going to calculate here the analog, digital. Just for your understanding we are telling here now. Active transducers and passive transducer we can discuss. Primary transducer and secondary transducers we can discuss. Electrical and mechanical here. These are important here. These three are important here now. classifications here. So one by one, we are going to discuss. I will tell all the definitions here. Now, only definitions are there. Later, after completing these classifications, we can go for the electrical transducers. We can go for the electrical transducers here. You consider active transducers and passive transducers are there based on the power supply, external power supply required here now. Based on that, we have classified this active transducers here now. So actually active transducers which does not require the external power source is known as active transducers. उसको external power supply का जरूरत नहीं है. That is called, the example thermocouple is there. Is there any external power supply is required for that one? External power supply जरूरत है क्या? Example I will tell that one. आप ओल्ड अभी तो मालूम नहीं, बट ओल्ड जनरेशन में फीवर आया तो ये मुंह में कुछ तो रखता था, मालूम है क्या? They can identify your temperature. Yes or no?
थर्मोमीटर.
थर्मोमीटर. उसको एक्सटर्नल सप्लाई का जरूरत था क्या?
नहीं.
कुछ तो सप्लाई का कनेक्शन दे के उसको चेक करते क्या? No. Now they are using the whatever the wireless and the digital we are going to use by giving the supply by holding now during the COVID situation they are going to check the temperature actually here now. So by without touching that part only they can, by using a sensors or the whatever the signals passing through our body, they are going to check that one. That is different. It is required. But old the thermometer, that is no need to supply was not there. Like that devices, those are active transducers we are going to call that one. The transducers which does not require the external power source, external power supply required nahi hai, those type of transducers are known as the active transducers. Such type of transducers develops their own voltage or current, hence known as self-generating transducers. The active transducers are also called as self-generating transducers. आप थर्मोमीटर में देखा होगा शायद, आपको टच होने के बाद inside some liquid we are using over there, the liquid is going to increase, then temperature जैसा decrease हो जाता है, it is going to reduce over there. That is the self-generating transducers we are going to call that one. The output signal is obtained from physical quantity only. Input physical quantity we are going to get that in here. So the example is nothing but piezoelectric crystal we are going to call that one. One material is there, piezoelectric. By folding this one, it is going to generate some voltage over there. No need to require any supply over that. One more thing, that is photovoltaic cell, solar cell. You consider that one. उसको तो supply चाहिए क्या? You can take supply from the solar cell, but the solar cell को supply दे रहे क्या हम? Is there any supply we are providing? Only the sunlight it is going to take. It is going to give the output. Yes or no? Solar panel, you consider that one. It will take the sunlight, will convert that heat energy into electrical energy. Yes, physical to electrical it is happened. So like that, tacho generators are there, thermocouples are there, solar cells are there. These are the examples for the active transducers. These are the examples for the active transducers here now. Next, we'll discuss the passive transducers. The transducers which requires the power from external supply source. These what it is done, they require the external power supply is required for that particular devices. Those type of transducers are called as passive transducers. They are also known as the external power transducers. इसको external power supply का जरूरत है. They are called as the passive transducers we are going to call here now. That is called strain gauge. Strain gauge को supply दे रहे हैं आप. And thermistor, that is also the temperature resistance which is going to depends on temperature. It is going to measure the resistance over there. So thermistor we have called that one. That is also the power supply is required. And just now I told that one, the whatever the heat detector or temperature sensor, the devices we are going to use, we are providing the battery supply now. Those are the external power supply is required now. So different types are there, different sensors are there, different equipments are there in the market now. So which transducer requires the external power supply? Those are called a passive transducer. The device or transducer which does not require the external power supply, those type of transducers are called active transducers. Those type of transducers we are going to call as active transducers. So next, analog, digital, primary, secondary, these transducers we are going to discuss in the next class. We will discuss that one. It will not cover here now in 2 minutes. So with examples I have to tell. So you have to remember this active transducers and passive transducer. What do you mean by transducers and what do you mean by resistance temperature coefficient? The tomorrow class, when I will start the class, I will ask the questions. You remember that one. Even you have to remember these types of transducers also. How many types of are there here now? Okay, these all the definitions you have to remember. The MCQ questions will come based on this one only. You have to prepare well for this one. You have to prepare well for this one here now. Just a minute, I will tell the absent roll numbers. I will take down attendance here now once again. Only 23 students are there. Roll number 1, roll number 2, 3 is present. Roll number 4, 5 absent, 6 is present. 9. Roll number 9. Roll number 9. Absent. It went. 13, 15, 16, 17, 18, 19, 20, 23, 24. अजय शिंदे, रोल नंबर 39. इनको कैसे मालूम हो जाते? When I will take the attendance, on that time only he is going to join. शिंदे अजय, अजय शिंदे, अजय शिंदे.
यस सर।
आपको कैसे मालूम? कोई इन्फॉर्म देते क्या अटेंडेंस ले रहे सर, आप ज्वाइन हो जाओ बोल के? कल भी आपको लास्ट 5 मिनट्स में ही ज्वाइन हो गए, अभी भी लास्ट 2 मिनट्स में ज्वाइन हो रहे हैं आप. आई विल नॉट गिव द अटेंडेंस अजय, याद रखो आप. अजय अनम्यूट करो.
हाँ सर।
आपको क्लास अटेंड करने का इंटरेस्ट नहीं है क्या?
करता है सर।
क्या करते हैं आप? घर में कौन कौन है? मैंने कॉल किए तो भी रिसीव नहीं करते आप. याद रखो बेटा, ये अच्छा नहीं है. आपको कॉल किए तो भी रिसीव नहीं करते. क्लास को अभी लास्ट 2 मिनट में ज्वाइन होते, 1 घंटा पूरा नहीं अटेंड करते, पर लास्ट 2 मिनट रहते ना तब ज्वाइन हो जाते अटेंडेंस के लिए. हम ऐसा हो गए तो अटेंडेंस नहीं देते आपको. पूरा 58 मिनट एब्सेंट होके लास्ट 2 मिनट प्रेजेंट हो गए तो कैसे होते?
करता हूँ सर।
It will loss for you peoples only. Academic loss for you peoples only. I told clearly your term work marks is depends on your attendance, your ISC marks, your chapter test marks. आप ISC को भी absent है ना? Roll number 39. हाँ, you are absent for the ISC 1 also. It will be a big loss for you peoples only. सबको ISC को 30 मिल गए तो आपको 12 भी नहीं मिलते. ISC में 0 है ना आपको. इस बार तो very serious, we are not going to provide any 1 marks. Single marks increase नहीं हो रहे. Already you know that one. Some issues are going on the universities. They are not asking anything as it is. They are asking the proof. If you are not submitted any ISC paper, means we should not have any proof. So we have to put absent only. अजय, इम्प्रूव होना है तो हो जाओ, ये सजेशन है. अभी भी टाइम है, स्टिल टाइम इज देयर. यू हैव टू इम्प्रूव लॉट. Okay, we'll stop here only and we'll continue in the next class. Ajay, you call me. After the class, you call me.